Hello again, this is Alister McGrath at Oxford University, and we're talking in this presentation about proof in science and religion. And you'll remember that in the last presentation we thought about how we might work out which of a number of possible explanations for an observation is the best. And as we saw, this doesn't necessarily mean that the best explanation is the right explanation. And in fact, it doesn't even settle the question of whether there's only one explanation. So we need to think a little bit more about the ideas of proof and evidence. Now, when I first began to study science as a teenager back in the 1960s, I was encouraged to think that science proved its findings with total conviction. For example, the chemical formula of water is H2O. And that's just the way it is. And it's very common for those who are committed to this outmoded warfare model of the relation of science and faith to contrast them at this point. Science, we're told, proves all its beliefs. Religion just asserts its beliefs. But as you might expect, it's not that simple at all. And here's the first point I want to make very clearly. The notion of proof in its rigorous sense applies only to logic and mathematics. Science tries to find the deeper truths that explain our observations, and it does this partly by asking what big picture of reality is best able to fit in all these observations. But you see, time and time again, we find these answers can't actually be proved. We can certainly provide good reasons for thinking they're right, but that's not the same as proving them as if it was some kind of mathematical proposition. So, to use more philosophical language, we can justify beliefs, but those reasons we give for believing certain scientific theories very often fall short of compelling truth. Here's a very good example. Charles Darwin believed his theory of natural selection provided the most elegant and persuasive explanation of the diversity of biological life forms on Earth. But he knew he couldn't prove it was right. And here are some words from a later part of The Origin of Species, which I think help us to understand this point. He writes, "A crowd of difficulties will have occurred to the reader. Some of them are so grave that to this day I can never reflect on them without being staggered. But, to the best of my judgment, the greater number are only apparent, and those that are real are not, I think, fatal to my theory." Now, I think you can see Darwin's point here. He knew he couldn't prove his theory was right, but he still reckoned it was good enough to cope with these anomalies, and it was better than anything else that was in the intellectual marketplace. Now, some scientists do suggest you can prove everything scientifically, everything that is trustworthy. For example, Richard Dawkins argues that science proves things by an appeal to evidence, where religion runs away from the evidence. Here's what he writes: "Faith means blind trust in the absence of evidence, even in the teeth of evidence." And Dawkins argues there is no need for faith in science because the evidence compels us to accept its truth. And we're going to look at his views on this matter as they're set out in the second edition of his well-known book, The Selfish Gene. Let me quote to you from this, and then I'll reflect on what he says. He writes, "Faith is a state of mind that leads people to believe something, it doesn't matter what, in the total absence of supporting evidence. If there were good supporting evidence, then faith would be superfluous, for the evidence would compel us to believe it anyway." Well, it sounds simple, but it's not. And the reason it's not simple is because it's obvious that Dawkins fails to make a crucial distinction between the total absence of supporting evidence and the absence of totally supporting evidence. Do you see the point? Let me make this distinction again. The distinction between the total absence of supporting evidence and the absence of totally supporting evidence. That's why we have to work out which is the best explanation, because there are so many explanations that exist, and we have to figure out which of them is the most reliable. A very good example is this. It's a debate in contemporary cosmology over whether the Big Bang gave rise to a single universe or to a series of universes, a so-called multiverse. And I have many distinguished scientific colleagues here in Oxford who support the first of these approaches, and also distinguished colleagues who support the second of these. There are reasons for thinking each of these might be right, but we can't prove it. And nobody is going to say people are mad to believe one or the other, because the evidence is not compelling. Both are real options for thinking and informed scientists at the moment. And those scientists have to make professional judgments about how best to interpret the evidence. But know they can't prove that their interpretation is true, even though they believe their judgment that this is a more reliable theory is defensible. Dawkins himself, I think, prefers the multiverse theory, but look, the evidence for that just isn't good enough to compel him or anyone to accept it. Now, the issue here is what's called the underdetermination of theory by evidence. And this is precisely what happens in the sciences, natural and social, when the evidence isn't good enough to compel us to prefer one explanation over others. And there's always going to be a degree of uncertainty in many cases about which of these explanations is right. I want to make clear this does not lead to relativism. All these views are equally valid. It just means being realistic about the degree of justification that's possible in many situations. We may prefer one theory over others, even though we may not be able to prove that it is right. And that's why the idea of the inference to the best explanation is so important in science. It means the scientific task is to identify possible explanations and then work out which of these seem to be the best. The task is to assess rival theories, realizing we may not be able to prove that one of them is right, but we can certainly say we think this one is the best. And there's another point we need to make. Scientific theories are provisional. They change over time as new evidence becomes available. And we just can't tell whether a theory that is well regarded today will be seen as wrong in the future. For example, most scientists before the First World War thought that the universe had always existed, taking more or less the form that we observe today. Yet, after the First World War, the work of the Belgian Catholic priest and astronomer Georges Lemaitre and George Gamow in the United States pointed towards the universe having an origin, an idea we now refer to as the Big Bang, and a scientific orthodoxy today. But back in 1910, it would have been seen as lacking any evidential basis. Science changes its mind, partly because it accumulates new evidence. Now, this emphasis on the provisionality of scientific theories is simply a natural outcome of the scientific method, and historians of science regularly point to theories that were considered to be the scientific orthodoxy in their age, but they're now regarded as incorrect. That's how people used to think. We don't think like this anymore, even though we use the same scientific methods in both cases. So in the next presentation, we're going to think about this point in more detail and explore how it might help us to think about how religious explanations work. I hope to see you again very soon.